So, today you got to use volume method, and it's important to understand visually what's going on. All right. So, this is not in your notes yet, but just stick with me and I'll get to your notes. So far, you've talked about two kinds of volume. If you have a region like that, and you were to revolve it around the x-axis, using x as a variable, then think what a rectangle would look like. If that rectangle got revolved, it would form a solid. What's that? Volume method. What are you looking at there? That's a disk. Okay, there is no hole in the middle. It's because the region goes right up to the axis. It's a solid disk. That then we know is pi r squared and yes, yeah? Okay. We then later on in set 81, I believe it was, say, well, what if you get a region that's got a gap in it, say this region here? If I revolve that around the x-axis, then this rectangle, as it gets revolved, would go, and when it gets revolved, because it's not right up against the axis, I have this big gap in the middle, we get a wash. We find the volume of that by taking the big circle, which is pi big R squared, and subtracting away the little circle, which is pi little r squared. The height is the thickness. This really small thickness is infinitesimally small dx. That's your view, right? All right. Now, today, imagine if we take either of those regions, it doesn't even matter which, and this slice, and instead of revolving it around the x-axis, we're going to revolve it around the y-axis. Now, imagine the geometry made. This would be a really thin slice this way, and it's revolved over here, and then back through the board. So it would go like this, and it would make something like that, right? Now, in terms of the thickness of it, it's not very thick. And so while students are tempted to say, oh, it's kind of like a washer also, pi big R squared minus pi little r squared. It's so thin that it's not even worth doing a wash on. It's more like if you took this paper, it's that thin, and to find the volume of it, rather than treat it like a cylinder problem, you unroll it and you treat it more like what's the volume of this rectangle problem, all right? That's the idea of a cylindrical shell. The beauty of it is that it allows you to use the other variable, x versus y. There's going to be some cases where, man, you definitely don't want to use x, you'd rather use y. Shells allows you to do that. It allows you to use the other variable. That's the key to having another method. Allows you to use the other variable that you might not if you didn't have that method. So that is wonderful. Let's talk about what the volume of that would be like. If we unrolled it, sorry, you're probably thinking, why did you make these notes if you're not going to use them? But if you unroll that, then it looks something like that, yeah? The volume of this is length times width times height. Let's go with the width. What's the width? Maybe I'll Scroll back up. What's the width? Say it out loud so I can hear it. Somebody's here saying it. I hear circumference. Thank you. That wasn't so hard, was it? You spoke out loud. What you've been doing since you were 1. Great job. Okay? When you unroll it, that edge down here comes from how wide it was around the cylinder. It's the circumference. This is the circumference, which is 2 pi r. That'll be a component to the volume. The height. How high it is goes to this length here. How high it is then will depend on the function. Okay? And the length is kind of a bad variable, but the one that I don't have so far, I have this dimension, this dimension. Length, I guess, by default is this dimension. What's that dimension? According to this, what does that have to do with the paper? What's that on the paper? That is that dimension. That's the thickness. And what is the thickness? If it's super small change in x, then it is dx. Okay? Now that's just one piece of paper. If I took a whole stack of these papers, all really thin slices, then I would start to get the whole solid. So it's an infinite sum of those. All right, that's the idea of the day. Let's go here then. Say we had this graph. Y equals x times x minus 2 squared revolved around the y-axis. Let's get the graph first. It's a positive x cubed shape with zeros at 0 and 2. And the 0 at 0, does it pass through it or bounce off of it? Passes through. And the 0 at 2, it bounces off. So the graph looks like this. The part that we're interested in is the part that's enclosing a region with the x-axis, so this region here. Now, typically we were revolving that in Washer and Disk problems around the x-axis, but this says to revolve it around the y-axis. Right? Now, before, we were revolving it, when we revolved it around the y-axis, we used y as the variable, right? And if I used y as the variable, the rectangles would look like that, and I'd get a washer. So you might think, well, okay, why not just use y? Why not use y? Say you did it by a washer. Then if you did it by a washer, and you used y, what goes in for big R and little y? You would have to solve this for x in terms of y, right? Do that. How do you do that? Yeah, okay. So if you're saying, I don't know, that's the truth. You cannot solve this because this cube equation can't be written as one equation of y. It would be 3 equations of y, minimum. Okay? It's not going to happen. Y is out. You're not going to take that equation and put in y terms. Not going to happen. You need to find a way. Y, actually, I didn't mean to cross that out. Y is out. Y is a no. If you're not going to use y, then we have to use x. We must use x. Now, if we use x in this situation, then the slices, if they're x slices, they need to go this way. That's how x works. It's a thin slice this way. If this kind of slice is revolved around the y-axis, then that slice doesn't make a washer, it makes this onion skin kind of shell, super thin shell. If I want the volume of this, then the idea is we're going to unwrap it and make it a thin piece of paper. This dimension, what did we say this part of the rectangle is when we unwrap it? That's the circumference, 2 pi r. And what is the radius? Is the radius of all these cylinders. Now remember, that's just one of these, but there actually are many of them. I have lots and lots of these cylinders within each other. So here's the R, here's the R, here's the R. It looks like the R is varying, it's changing. So what is the R? It's X. It's just whatever the X is. When I look at the slice at 1, well, the radius is 1. When I look at the slice at 1.2, the radius is 1.2. So the radius is always whatever X is. What about the height? This dimension of the sheet of paper corresponds to this, and that is just the function. And what about the thickness? The thickness is dx. So, if I take that and add many of them, the volume is the length times the width times the height, or 2 pi x for the width, f of x for the height, and the thickness is dx. And the limits of integration are from 0 to 2. Put that in your calculator, please. Typically, we put the 2 pi out front. Don't forget the 2 pi, especially those of you who forgot the constant pi in the test. Now you're going to not forget a constant 2 pi. Surely this isn't too bad to integrate, but we'll focus on the concept and leave the integration to the calculator. I'm getting something like 6.702. How about you? Yes? I believe I did that correctly. Or is that what you got? Or are you just waiting for Kylie to do it for you? Kylie? Is that what you got?
What did I do wrong?
What did I do wrong?
No, what did I do?
What did I do wrong? Maybe you did something wrong. Maybe you did something wrong.
Always X times X.
Man, that seems really hard. You said x times -2 instead of x minus 2. Okay. All right. Dewey, can I get a, I got 6 now? You still don't get a 6. What the heck? Why not? 2, 1. You got 8?
Lenny, you're forgetting an X.
You're forgetting an X in there.
I am? You forgot the 2 pi. The 2 pi, you're good to go.
Classic.
Don't forget the 2 pi. Write that first. You type in 2 pi before the integral, then the integral. I guarantee you, if you say I'll do the 2 pi later, you won't. Okay, type it in just like this. Did you get 6 then? Maybe?
Yes.
Okay, cool. All right, let's proceed then. Let's talk a little different. It's conceptual, so I don't want you to memorize that. That's maybe for reference later, right? Find the volume of the solid created by revolving x equals sine y, the y-axis on 0, on y between 0 and pi about the x-axis. What the heck is going on? Let's first graph it. What does x equals sine y look like? It's the sinusoid going up, yeah? It goes through the origin and like this. Right? 0 to pi would look something like that. And if it's about the x-axis, then the region would be reflected this way, and I'm getting something like that. Right? With me? Now the problem is, or the question is, what about the variable? Now this slice, if I used a slice like that, it would be awesome in x, but the problem is that equation's not in x terms. We probably want to use a y slice, yeah? So I'm going to redraw this real quick. Say I take this region. If I use a y slice, then does that mean the slice goes up and down or side to side? Side to side. If I take that slice and revolve it around the y-axis, then I get something like that, and it's another one of those cases of a super thin slice, yeah? I didn't change my notes, did I? This is the same as what's on there. All right. So in this case, then, we're getting a cylindrical shell, and it would really unwrap more like this way if I unwrapped it. All right. So now, when I unwrap it, so right now it's like this, and I'm unwrapping it. So now this is going to be where the circumference is, which circumference is 2 pi r. What's the radius of these slices? There's the radius. That's not x. I'm going up and down. Now the radius is y. Okay? This distance here corresponds to this distance. Isn't that just the distance to the function also? I don't want to call it f of x because I think it's going to be in terms of y. And the thickness. Is the thickness of this thick or small change in x or small change in y? Small change in y. dy thick. All right. So the volume then is 2 pi times what? So here's the circumference is one dimension. There's the width, 2 pi y. This dimension is the function in y terms, so times sine of y, and the thickness is dy. The limits of integration are 0 to pi or 0 to 1. Given that you're talking y is the variable, don't I need y values here, so it's 0 to pi. All right, throw that in your calculator. Tell me the volume. Type in the 2 pi first. What'd you get? Something like 19.7392. All right. Okay, that's the idea. Let's try, you try this one. Are you ready? Sorry. Your answer is 8. Fish? What'd you get? 8.376? 7? 8.377 or 7.8 would also be acceptable. Okay. Now, here's the gotcha to this. I was giving you first quadrant problems so far. Actually, let's go. Oh, sorry. I got my notes out of order here. Is this the next thing in the notes? I thought I switched this, but I guess not. Okay, let's try use it. We used y once already, so I don't know why I'm saying we're jumping to y, but let's talk about what y looks like. Say you looked at the region here, y equals the square root of x minus 2. That's the square root graph shifted how? Right 2. Okay, so that looks like that. The x and y axis is y equal 4. So I have this curve, the x-axis, the y-axis, and y equals 4. Here's this crazy region. You follow me? All right? If this is revolved around the x-axis, then we get a volume of revolution. Now the question then is, should we use x or y? Honestly, the first times through in the book, they'll tell you which one to use. Right? My contact problem. They use x or y, but eventually it's going to be kind of like area problems where you need to measure one against the other and know what's the strength or weaknesses of each approach. If I were to use x, if I used x, then wouldn't the slices go this way? Yeah? Are you with me? All right. Now if the slices go this way, this would be a disc, this would be a disc. But the problem is once I get to here, then I'm talking washer. And so if I use x, then it's 2 integrals. What if I talk that region and I used y? Now, first of all, what does the slice look like if I use y? Instead of slicing this way, y slices go this way. If you look at y slices, isn't it always the same kind of situation? The right is the curve, the left is the axis, the right is the curve, the left is the axis. If it's y, it only requires one integral. Now, that's then obviously easier, so we're going to go with y. If I use y, then you need to, after you decide, all right, this is what the slice is going to look like, I'm going to use y, then you decide when I revolve that slice, what's made, a washer, a disc, or a shell. When I revolve that kind of slice, what's made, a washer, a disc, or a shell? A shell, all right? Now, I didn't decide shells first. I decided the variable first. Students always get this confused. They think, oh, should I use this, or shells, or wash? You don't decide that first. You say, which variable is the easiest to use in terms of number of integrals and equation, and then based on what that revolution looks like, that's what decides shells. One integral is easiest, and so we're going to use a y, which means shells. So what is the integrand here? If I unroll this, then what's this dimension here? 2 pi y. Okay, the radius is y. What's this dimension, which corresponds to this length? That is the function. Okay, that's the function. And the thickness is dx or y? dy. Okay. So the integrand would look something like 2 pi from, what are the limits of integration? 0 to 4. is the low y to the high y of y, the function. Now the function isn't given in x terms, it was given in, or in y terms, it was given in x terms, so we need to rewrite that. What is the function in y terms? Y squared plus 2. Okay, so you would have to sometimes do a little rewriting and put it in y terms. Integrate that, and you're good. Now would that be the same as if I said, forget it, I'm going to use x and do two integrals and disk and watch, would the answer come out the same? Yeah, it would come out the same. It's nice to have a check. Now you have two ways to do a problem. Any problem you can check against each other, and that's handy. But that should agree. Try this one on your own. I guess I will say you may use a calculator. If you're not new to those, I will help you. If you have questions, let me walk through it. I'm having trouble. It's okay to ask. These kick my butt when I. So, make sure you're on the right track. X or Y? Y. Y. If you do X slices, then it's going to suck because in that region you got parabola minus itself. That's not good. And then this is line minus parabola. That, at the minimum, is two integral, and the parabola minus itself. I don't even want to go there. So X stinks. X is bad. Y is good. If I do Y, then my slices will always be the same right minus left situation. The right is the line, the left is the parabola. The right is the line, the left is a parabola. So right away I can see that y is better because it's one integral, and this equation's already in y terms anyway. So that's good. All right, so now that I've decided y, now I need to figure out what's made. Is it a shell, a washer, or a disk? Yeah, if you look at one of these and reflect it and then connect it, it's a really thin shell. For me, when I run this, I looked, I said, look, why isn't it a washer? Why isn't it a washer? It looks kind of like a hole in the middle case, and it really, at the end of the day, you really just need to distinguish between this, when the super thin level is this, when it looks like that, that's a washer. When the super thin is here, this is super, that's not a washer, that's a shell, okay? Look at your picture, the picture is required. And if it's more like, oh, I could unwrap it and make it a piece of paper kind of thing, that's a shell. You're not unwrapping this to make it a piece of paper. That's not a piece of paper, no matter how you unwrap it, okay? So it's a shell kind of thing. And then you talk about what does it look like if you unwrap it. When it goes this way, you unwrap it this way. And now you decide, all right, what's the length, width, and height? One of the dimensions will be the circumference. One will be tied to the function, or it may be a little more complicated here. And one will be dx or dy. I'll give you 1 more minute to finish that and give me a number, and I'll get my number, and we'll compare. I have parentheses here. Uh-oh, we got a negative, that's not good. Oh, it's because I switched them. Okay, are you ready? Your answer is? Anybody, shout out their answer who has guts. Y'all gutless weasels. Kylie, go. It's okay to be, I just want a number. Say 7. Okay, that's wrong. Go ahead. Philip, what'd you get? 2. Mitch Gardner, what'd you get? 61, okay. Miller? 61. Did I make a mistake there? Oh, yes, I used the wrong limits of integration. No, I didn't. 61. What'd you get? Neuro. Somebody. 61? How about you, ladies? Your answer? Wow. What? That's what I got.
You forgot the square.
That's what I got. So did we do something wrong or did they do something wrong? Okay, I got 42. So let's go here. This radius, is it x or y? It's y. Cool. This distance here. This distance goes to this distance. This distance varies on both edges, the right and the left. And so to make this positive, right minus left, what's the right? The line or the parabola? The line in x terms or y terms? Y terms. So that right should be 4 minus y, and the left should be the parabola in y terms, which is y minus 2 quantity squared, and the thickness is dy. So the volume should be something like 2 pi y times a big old set of parentheses, 4 minus y minus 2 squared, dy from 0 to 3. And I did that, I got 42.4115. And I believe I did that correctly. Okay? All right, now, the last gotcha to this, the last warning to is you could be a total moron and get discs and washers correct. Because the square will cancel out you're not knowing how to make it positive. You know, even if you set it up so that one of the dimensions was really a negative, the square would make it positive and get a positive volume. Shells is far more unforgiving. Okay, there's no squares in shells. And if you set up one of the calculations and it should be negative, you'll get a negative volume. And you're going to be thinking, huh, why? It won't erase that error. So you've got to be very careful. Be careful to make every dimension positive. To make it positive, use right minus left for horizontal distances and upper minus lower for vertical distances. If you do that, you will get a positive outcome. So let's say we looked at y equals x squared minus 2x, which looks a lot like one we've done before, but instead of being downward opening in the first quadrant, it's upward opening, and the region is in the fourth quadrant. The zeros are 0 and 2. We're revolving this around the y-axis. Now, I don't want to write that parabola in y terms, so I'm going to do this in x. I want to use x. If I use x, then what's made? A washer, a disc, or a shell? A shell. All right, so it's a cylindrical shell. Volume is this dimension here, comes from the circumference. It's 2 pi. And the radius. The radius is x. And is x going to be positive? Is the region I'm talking about positive x's? Here's the region from 0 to 2. Are those positive x's? Yes. It is. Okay. Now, I will say this. If I had given you a region like this, then you would have had to have said 2 pi opposite of x. I didn't give you that. But here, look here, the height. The height here is the function. But the function there is negative. And if you use that function value, you're going to get a negative volume. The function is negative. So if you do upper minus lower, then it's 0 minus the function. Or in essence, for the height, you need to use the opposite of the function. The opposite. Because otherwise you're going to get a negative volume. All right? So the volume is 2 pi. X can be fine. It's already going to be positive. But I need to use the opposite of the function to get a positive volume. So instead of x squared minus 2x, I'm going to use negative x squared plus 2x from 0 to 2. By doing that, you'll get a positive volume. You'll be good to go. Okay? So I'll say this here. If you get a region like this, if you revolve it, here you would be careful here. Both x is negative and y is negative. If you got a region up here and you revolved it, then the x would be negative, but the y would be positive. So you'd be okay with leaving the function the way it is, but the x you'd have to negate. So you have to pay attention to what quadrant am I in? I need to take steps to make a positive volume. Are you with? All right. Question on set 86. 86. Hit me. 12. 15. 12 and 15. All right. 12 and 15. 86. Yeah, 12. It's kind of kooky. First time I did this problem, I wasn't sure what was going on. Okay. Wow, this is funky on two parts. All right. So, first of all, it says use logarithmic differentiation. Remember, there's two reasons you use logarithmic differentiation. One is because you have a variable exponent, like sine of x to the x. You use logs there to bring the exponent down. The other is because you have a terrible mess of stuff, and log rules allow you to separate it into little pieces. Here, they're asking you to use logarithmic differentiation, so you don't have to do a three-part product rule. They're trying to help you out here. So, if I take the log of both sides, the left side can stay for a second. The right side, with a log, in log rules, you could break this into the sum of log of x plus the log of sine of x plus the log of cosine of x, just like that. Yeah? Now, they ask you to differentiate f prime and all that. So we're going to take the derivative on both sides. When you take the derivative of the left, it's a function within a function, so we must use the chain rule. And the derivative of the outside is the derivative of log of blah. Derivative of log of blah is 1 over blah. So 1 over f, yeah? But then by chain rule times the derivative of the inside, which is f prime. That's actually what they wanted you to find. So you might have thought, what are they talking about, f prime over f? They're trying to actually, they saved you a step by asking you that. You didn't have to move over the f like we normally would. Once we find our answer on the right side, we're going to be done. That's f prime over f. What's the right side's derivative? 1 over x plus, now we're talking chain rule, function within a function, so be careful, chain rule. Over sine of x times the derivative of the inside, cosine of x. You could also call that cotangent of x, I reckon. And log of cosine, derivative of the outside is 1 over cosine times the derivative of the inside is negative sine, so I imagine they might call that negative tangent. But as far as I'm concerned, you could call it good. You with me? All right, cool. 15, question on 15. 15. Y equals e to the x squared. On the x-axis from 1 to 2. Y equals e to the x squared. I'm not familiar with that graph, so let me think about it here. At 0, e to the 0 is 1. On the right-hand side, as x gets big, e to the 1 is about 2.7-ish. And it's going to grow really, really fast now, so exponential growth is pretty intense anyway, but now it's growing even faster. So here's the region. It's some kind of amped up version of the E curve. You're revolving around the x-axis. I think I added in something, yes? I added in the second part to help prepare you for today's lesson, actually. When you did part A, do you have a question on part A or just the part I added B? Just the added part, okay. So, B, if you go around the y-axis here, And yesterday, you would have thought, doggone it, if I go around the y-axis, I have to use y, and I would get lots of washers, and I would probably need two integrals because it's two different situations as far as the radii. So if you were to have done this yesterday, the intention was you'd have said two sets of washers, one set in the region one set in the region here where you're just going from the one line to the two line. That would be one set of washers. And then the other set would be up here when you're talking from the curve to two, the curve to two, the curve to two. This region up here in the black would be a totally different situation. So two washers. The first guy, the green section. I know it's from 1 to 2 in x, but I'm using y as the variable here. So what are the y limits of integration for this green region? What's the low? 0. That's the easier part. The harder part is what's the high? Well, that goes to when the curve is at 1, so that's at y of b. Now, in terms of the integrand, because it's a washer, it's big R squared minus little r squared. What's big R? Here's big R, here's big R, here's big R. The big R is always 2. Little r. Here's little r, here's little r, here's little r. Little r is always 1. In other words, we could have done that geometrically. But the top one, not so easy. The top one, or the black section, starts at here, E, and goes to what? Where's the end? E to the fourth. Yep, E to the fourth. When x of 2 goes into the equation, you get e to the fourth as a y. What is big R? Big R is still 2. Little r. Here's little r. It's getting bigger and bigger. Little r seems to be varying. Little r tends to go to the curve, but it needs to be in y terms. So now we need to put that in y terms. Do that. First we log, yeah? When we were...
Good morning, Devlin Jaguar. Please rise for the Pledge of Allegiance. Please begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
For tonight, for voice basketball, remember that the cost is $6 per student. No activity passes are accepted, as this is a state playoff game. This will be the case on Friday for our girls getting into our season.
We would like to congratulate you for raising $7,725
I need to get you an answer here in just a second.
Thank you so much for your support of Alice's wish to travel to Disney World. We are still working towards our goal of $10,000. If we do this, not only do we make Alice's wish come true, we earn the honor of bringing her Devlin next year to participate in one of our school events. See the financial office for more details if you would still like to donate towards this amazing cause. Donations are due by February 28th.
It's not too late to get your tickets to the final weekend of Musical Curtain, which runs Thursday, Friday, and Saturday at 7 p.m. Your tickets are only $8, and Thursday night's performance includes a raffle. Buy your tickets today at lunch or see the banner in front of the cafeteria for the online ticket website. Y'all pick a great show and support your performing arts.
Tomorrow, University of Northern Colorado will be visiting with prospects.
61.1004. How about you?
The girls basketball team will host Erie Tigers this Friday night at 6 p.m. for the second
Now,
round
the
of
beauty
the
of that is you could check it with
Please come
shells,
to the
now that you know shells, because it'll be a heck of a lot easier to use shells.
You're in luck. Mr. Abel will be taking a group of students to Italy, France, and Spain in June 2020. And Ms. Ford will be taking a group of high school students to England in July 2020. Both teachers will host a joint activity on Tuesday, February 26th from 6 to 7:30 p.m. in the auditorium. Come find out about both trips and decide which one's best for you. Potential travelers and their parents should attend.
Senior high students, 11th graders, if you're interested in taking the AP English language exam, please turn your signed forms into Ms. Harrington by Friday, February 22nd. If you need a form, you can stop by counter and pick one up. Thanks.
Junior high students, there are flyers in the office for middle school tennis, which starts on Monday, April 1st.
Uh-oh.
Practices will be at various locations throughout the week with matches on Saturday. We have all levels of experience, so beginners are welcome.
Dazzling Dad, congratulations boys on a great basketball season. Ladies finished 54 and almost reached 14-5. Varsity plays in our first round of the playoffs tonight, Wednesday at Columbia High School 7 p.m. Let's pack the game with our fans. Go Jazz.
Don't forget that the game is a whiteout. That's all your announcements. Have a great day.
162.985 is what I got, sorry. Okay. That's it. There you go. You know what? You have your, did you finish your first presentation? Have a good day, people. Yeah,